All right, this is a deeper dive into trilobites and sexual dimorphism. And this, as far as I can tell, is a self published WordPress publication. But it's not an unknowledgeable one, and that doesn't necessarily make it bad. I think this is saying things that a lot of people suspect and would like to believe, but I think the statistical rigor is not here, and so more mainstream trilobite paleontologists would say, yeah, maybe even probably, but come back when you got, firmer numbers. But let's look at this thing because I think it's interesting, and yeah, I think this may actually tell us something. So, when dealing with these trilobites, and this is all from this publication, Chiang Gu is the person who has put this together, and you can actually see that there are some differences which don't look as though they could be differences in fossilization. And these are going to be members of the same species. They're from the same formation. There's a formation in Morocco that gives Devonian trilobites, and these are them, and they are lovely. They used to be quite inexpensive, but since then they don't have as many. They're not finding as many, and so you see, the prices have gone up, which they probably always should have. They're amazing fossils. But yeah, there's a kind of a whole paleontology industry there, which is good and bad and problematic in different ways. It is helping people to some extent, but it is a limited resource to another extent. And yeah. Anyway, they're great fossils. Let's use them for what we can while we can. But you see these differences. You see some that are actually, boy, that's kind of wide, and this one that's actually kind of narrow. And it doesn't look like either of them has been folded, during fossilization. This appears to be same number of body segments, no preservation of legs in these, because if we had preservation of legs, we could look for differentiated legs. Right about here is where we would expect to find them. If that is actually a male. So we cannot confirm that. So let's treat these as a pretty reasonable guess. Yeah. Self-published 2021. All right. And there we go. So let's jump up here. This is a let's read. It's like a let's play, except that nobody's going to watch my Twitch channel. Yeah, that's going to age very poorly, I'm sure. There is sexual dimorphism in a lot of extant arthropods, including in horseshoe crabs, in limulus type crabs. And yeah, you can see a fairly big difference even on the outer side, the sort of top side. If you flip these over, yeah, there's a different arrangement of plates. I don't know if you've ever sexed a crab, but yeah, the male have a little part that's kind of narrow in the center, and the females will have a wider plate in the center. And proper invertebrate biologists have names for all these things. Good for them. Great for them. They're going to be plates that are usually stretched. So usually the female is going to have larger plates or covering greater area. The idea being that the female is carrying either eggs after they've been fertilized or eggs that are about to be spit out for fertilization. And there wouldn't be an advantage in the male having that sort of extra space and not using it for something. Yeah. And so here you go. So this is the conjecture that you will have a sort of a narrower body with a kind of a V-shaped pygidium in male trilobites and more of a U-shaped pygidium and a little bit wider body in the females. And he starts out with triarthrous trilobites from New York. And these are the ones that are beautifully pyritized. And here you can see some that he is calling male and some that he's calling female. Now, in these trilobites, the ones that have the eggs, they're being identified as female because they have these little, see the little dots there? Those are the little fossilized eggs sort of collected together, maybe in a pouch. And those he's identifying as female. I don't think there's a lot of difference between the actual body shape and size, although you could say some of these are maybe a little wider. But one thing he notes is that all of the antennae on all of the presumed female trilobites are uneven. Now, that could be a fossilization thing or a predation thing, but they are quite even on all the ones that do not have eggs under there. So possibly there is a sort of a symmetry-based dimorphism. And then we go on. This is what he would identify as female. That would be identified as male from the same place at the same time, presumably something. So here would be a small male on top of a much larger female. Female is here. The male has the more long V-shaped body, so female on top of the male. Yeah, so not a normal mating position. Male and female there, and let's just look through. Can you spot which one he's calling the male? Yeah, and these are the same type of trilobites, same species, but there is a real difference in the way these are organized, and they do tend to fall into two groups. Now, if we wanted to turn this into proper science, what you'd like to see would be measurements of a whole bunch of these, and you'd like to show that there are two populations. You'd like to show that every place that you get this kind of trilobite, you get both the males and the females. Or if you don't, you'd like to have, some explanation for why. Because whereas they might sequester themselves at some points, at least during mating, they're going to have to be close together, we would think, for that to work, There's your male and female, male and female, male and female. And the cephalon tends to be roughly the same size, but it's the thorax where the differences are, and we know that's where the clasping appendages would be underneath if those were preserved, like in those other trilobites where they were preserved. So maybe. Potential male and female, his and hers, his and hers. Those aren't very well preserved or convincing, but there they are. And a male on the left and potentially a female on the right over here. And so there you can see them just isolated together, and there is a little bit of a difference there. One's a little wider than the other. The body segments are kind of even on this one. They kind of taper on what this person is calling the female. Here you have a couple of crotalocephalases, which are from that Moroccan formation. Potentially, male and female. Phacops, great looking phacops. I guess they're calling it Morocops there, and I think it's not Phacops anymore anyway. It would be Eldridgeops if it was in that genus. It's a Phacopid anyway. And these almost look like they're flexed differently, but that long sort of pointy pygidium and lower segment is right about where the claspers should be. So potentially this difference is actually what the author is saying it is. The speculatively pointing out differences in head shape as well. So let's just scroll through some of these trilobites. Let's have a look at some of these things. The male and the female here. There we go. I would say I find it compelling. I don't necessarily find it completely convincing, but it is compelling. It does make a lot of sense. I'm just not sure if this is the thing, and that's where you have to watch for confirmation bias coming in. These are just, wow, really different from each other, despite being in the same species. Those as well, pretty bananas, They're not necessarily bigger than the other. This is that giant trilobite you'll sometimes see from Morocco. It'll be in museums, it'll be sort of yellow color, and they're just giant, massive trilobites. There you go, potential dimorphism. And then Harpatid up there, that's the ones that have this sort of halo around them. And people aren't sure if they use that to kind of scoop stuff up, or was this kind of a resting place for eggs on the female, but then what's it doing on the male? Does it have some sort of sensory function? Undetermined. Little assemblages with male and female together. And there's Elrathia, the famous one from up in Utah. And so this one would presumably be a male with this sort of V-shaped backside, and this one would be presumably a female. So I don't know if it's real, but I've looked at my trilobites enough, and I think there's at least a possibility. And so, yeah, we can look through the trilobites and see if you can figure them out, especially in the cases where we can actually see more than one. Here he's comparing slipper lobsters, showing the differences. So that's probably enough. And yeah, guppies for this. But I think an interesting study with a lot of data in the form of potential dimorphic pairs of the same species from the same place and the same time. So this would be the start of how you do it, and then the end of how you do it would be a whole bunch of math and showing you have some kind of significant difference there, or something that you can point to and say, here, this is the feature that defines them. So thank you very much for Trilobites sexual dimorphism. Quite the journey. Yeah. And yeah, thanks also to the person who did all of this right there. All right, that's enough.